All right, so for section 10.1, we're going to talk about lines, but we're going to talk about lines and how they are connected to tangent and connected to trig. So, as you well know, the slope of a line is just equal to the rise over the run, right? And so then, if I think about, okay, I've got a line here, it looks something like this, right? So if I measure my rise, or excuse me, if I measure my run, so in the horizontal direction, then I measure my rise, I create a right triangle, all right? And this right triangle has an incline of theta, and the line has a slope of m, right? So we always talk about or use m for slope, right? So if I've got some kind of change in y over change in x, right? Then the tangent of my angle theta would be equal to y over x, which just means that the tangent of the angle that's created is really just my slope. Okay? So this is what I'm going to look at to answer questions about how the slope is related to the tangent of the angle. All right, so let's look at tangent of pi over 6. All right. So the tangent of pi over 6. So I've got a radian angle of pi over 6. So I go to my unit circle and I find that my y value is 1/2 at pi over 6. And my x value is square root of 3 over 2. So it's just y over x. And so my goal here is to figure out what the value of my slope is. Right? And so now it's just algebra, so I'm just going to flip the fraction. So 1/2 times 2 over the square root of 3. 2's go away, so I have 1 over the square root of 3, but we don't like that. So I multiply it by the square root of 3 over 3, and I get the square root of 3 over 3. All right? So this line would have a slope, or this angle would have a slope of a line as the square root of 3 over 3. And then the next type of example that I want to look at is finding theta. But we're going to find theta in degrees and radians. All right, so looking at this, finding theta in degrees and radians, when we are given 2 points. So we're going to have a line that passes through 2 points. Let's say 1 and 6 times square root of 3, and 0, 5 square root of 3. All right. So the first thing that I need to figure out is my slope. And I calculate slope by doing the y2 minus y1 over x2 minus x1. So I'm going to say m would be equal to, I want to use, let's use 6 square roots of 3 minus 5 square roots of 3, just to keep our signs a little more simple. And then 1 minus 0. So I'm left with a square root of 3. Okay, so I have a line that has a slope of the square root of 3. All right, this takes a little bit more trial and error because you kind of have to go look at your unit circle and figure out what tangent value, because what I'm really looking at here is what tangent of theta results in the square root of 3. All right, so if you don't get it right the first time by looking at your unit circle, that's okay, because what I have to do is find y values, or y over x, that gives me the square root of 3. All right, so I'm going to try, let's try a pi over 3. Okay, so I'm going to let theta be pi over 3. All right. So if the tangent of pi over 3, all right, the y-coordinate is the square root of 3 over 2. The x-coordinate is 1/2. So if I just flip the fraction, I'm going to come right here. So 3 over 2 times 2 over 1. Great, I get the square root of 3. So the value of theta in radians is pi over 3 radians. And then if I look at the unit circle, and the corresponding value for pi over 3 is 60 degrees. Right. Okay. So that is how you can go about finding the slopes of lines in relation to tangents. And these two examples that I've done, these are pretty well the two examples that are on the homework. But if you have any questions, please feel free to email me. And as always, have a great rest of your day.